Good morning, everybody. I hope you all enjoy my videos, and now I am going to discuss about capacitor and capacitance. Let's start our discussion. Capacitor and capacitance. Okay. Then what is capacitor? Capacitor is a device which can store some charges. It may be conductor or it may be insulator. Let Q charge is given to a body, then the electric potential of the body increases from 0 to V. We know that Q always directly proportional to V. That is, if we supply more charges, then the electric potential of the body also increases. Now we can write Q is equal to C into V, where C is a proportionality constant. Proportionality constant known as C is known as capacitance of that body. C is known as capacitance of that body. Of that body. Okay. Therefore, we can write C is equal to Q by V. Okay. Therefore, we can write C is equal to Q by V. When V is equal to 1, then C is equal to Q. Therefore, to increase the unit potential of the body, the amount of charge required is equal to the capacitance of that body. Okay. The unit of C is Farad or F in SI system. Therefore 1 farad is equal to 1 coulomb by 1 volt. Dimension of C is m minus 1 n minus 2 t 4 I2. Okay, you already know the dimension of coulomb and dimension of volt. Unit of capacitance in CGS system is step farad or ESC. Now, on which factors does the capacitance of a conductor depends? First, surface area. Now, our subtopic is factors on which the capacitance of a conductor depend. Okay. First, surface area of the body. You know, when the surface area of the body increases, then the capacitance also the body increases, because the charge of a body always lies on the outer surface area of the conductor. That is, when we take some different kind of bodies having same volume, let this is a sphere and it is a cylinder having same volume. Since the surface area of a cylinder is greater than the surface area of the sphere, therefore capacitance of cylinder is more than the sphere, because the surface area of the cylinder is greater than the surface area of the cylinder. Okay, that is volume, two volumes are same. Capacitance of sphere is C1 and capacitance of cylinder is C2. Now C1 is less than C2. When two bodies are hollow inside. Okay. On the second factor, the presence of other bodies. Presence of other bodies. That is, let us consider a body is charged by plus. Now the body is fully charged. To increase the capacitance of the body, we introduce another body near to the body, the charged body. Due to the electric induction, the insulated body is charged by oppositely charged at the near side and same charge on the away side. Clear? This negative charge also attracts more positive charge in the of the charge body. Therefore, it can get more charge. It can get more charge. If we earth the insulated body, then the free charges goes to the earth and the whole body is charged by negative opposite charge. I mean, here it is negatively charged. Then the charged body gets more charge. That's why the presence of another body increases the capacitance of a charged body. And third point is the capacitance of a body depends on the medium or surrounding. Let us consider the body. This plate is charged by positively charged, and by method of induction it is negatively charged, and the plate is arched. The capacitance of the body is C. The medium between the two plates is air or vacuum. Now, to increase the capacitance of the system, we insert some dielectric medium like felt or paper, etc. Okay. Now we fill up this place or fill up the blanks between the two plates by felt. Due to the electric induction, some electric dipoles are created inside the plates. Plus minus plus minus plus minus due to the electric induction. By this process, this positively induced charge can this positively induced charge can attract more positively charged. Okay. By method of induction, there should be negative induced charge, and in this area there should be positively induced charge. This negatively induced charge attracts more positive charge in this plate. Therefore, the capacitance of the system also increases. In this way, we can increase the capacitance of a conductor. Now, we are to find out the capacitance of a spherical conductor. Capacitance of a spherical conductor. Let R be the radius of the conductor which is charged by plus Q charge. Let capital R be the radius of a spherical conductor and plus Q is the amount of charge of the sphere. And we know the electric potential electric potential of the sphere is how much? V is equal to is V. Okay. Therefore, V is equal to 1 by 4 pi epsilon 0 Q by R. Therefore, Q by V is equal to 4 pi epsilon 0 capital R. This is in SI system in air medium. We know since Q by V is equal to C, therefore C is equal to 4 pi epsilon 0 into R. This is the capacitance of the charged sphere in air medium. When we introduce a dielectric medium inside the sphere, then the expression will be 1 by 4 pi epsilon 0 K into Q by R, where K is the dielectric constant of that medium. Therefore, Q by V is equal to 4 pi epsilon 0 into K into R. Therefore, C is equal to 4 pi epsilon 0 K into R. Okay. Our our next topic is the potential energy stored in a charged conductor. Potential energy stored in a charged conductor. We know potential energy, small amount of potential energy du is equal to q into dv. Okay, where dv is the change of electric potential electric potential of a conductor, q be the charge of the conductor, du is the change of potential energy of it or of this conductor. Okay, again we know q is equal to c into v. Okay, therefore du is equal to cv into dv. To find out the electric potential energy stored in the charged conductor, we are to integrate both sides. Therefore, potential energy of the conductor is equal to u is equal to integration cv dv. This is equal to, and the lower limit is 0 and upper limit is v. Therefore, this integration turns to half c v squared. This is equal to half c v squared. Okay, this is the electric potential energy stored in a charged conductor. Now we are going to find out the equivalent capacitance of some capacitors connected in series and parallel. Equivalent capacitance of capacitors are connected in series combination. Okay. Let us consider some capacitors having capacitance C1, C2 and C3 are connected in series with a cell having potential difference V. Let C1, C2 and C3 are the capacitance of three capacitors. Okay, they are connected in series. Series with a cell, electric cell or cell having potential difference V. Now, V1, V2 and V3 are the potential difference between the two plates of the capacitors respectively. Let V1, V2 and V3 are the potential difference between the two plates of each capacitor respectively. Respectively. Okay. Therefore, V is equal to V1 plus V2 plus V3. Since these capacitors are connected in series, therefore the charge stored in each plate of the capacitor is numerically same. That is plus Q, here it is minus Q, this is plus Q, this is minus Q, and this is plus Q, and this is minus Q. Okay. Now, charge on each plate of the capacitors is Q. Okay. Therefore, V1 is equal to Q by C1, V2 is equal to Q by C2, and V3 is equal to Q by C3, and V3 is equal to Q by C3. Therefore, total potential difference V is equal to V1 plus V2 plus V3, or V is equal to Q 1 by common 1 by C1 plus 1 by C2 plus 1 by C3. Let C be the equivalent capacitance of the capacitors. Capacitors. Therefore, 1 by C is equal to V by Q. From the previous last equation, we can write, therefore we can write 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is the relation, or this is the expression of equivalent capacitance of the capacitors. Okay. Now, our next topic is to find out the equivalent capacitance of the capacitors connected in parallel combination. To find out the equivalent capacitance of capacitors connected in parallel combination. Okay. Let us consider three capacitors having capacitance C1, C2 and C3 are connected in series with a cell having potential difference V. Since these capacitors are connected in parallel, therefore potential difference between two plates of each capacitors are same. Okay. And the charge stored in the capacitors are different. Let us consider Q1 is the charge stored in the first capacitors. Q2 charge stored in the second capacitors, and Q3 charge stored in the third capacitors. Here Q1 is equal to C1 into V, Q2 is equal to C2 into V, Q3 is equal to C3 into V. Therefore, total charge of the system Q is equal to Q1 plus Q2 plus Q3. This is equal to C1 plus C2 plus C3 whole divided by V. Let C be the equivalent capacitance of the capacitors. Therefore, C is equal to Q by V. From the above relation, we can get Q by V is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Therefore, C is equal to C1 plus C2 plus C3. This is the expression of equivalent capacitance of the capacitors connected in parallel combination. Today, I finished my discussion in this chapter. In future, I shall discuss about capacitance of the various type of capacitors and Van de Graaff generator, etc. If you like my videos, then please click the like button and please subscribe my channel, and thank you for watching my video.